Hello, everyone. It's Wilhelm Wassler here, and I just want to welcome you to our second workshop that is co-hosted between the GFRA, the Global Foot and Mouth Disease Research Alliance, the EuFMD, and the CCFMD from OIE. Now, before I start and introduce you more to our workshop, which today is about vaccination against foot and mouth disease, principles and practice, we want to just play a welcome message from the CEO of the GFRA, Alejandra Capozzo.
Hello, my name is Alejandra Capozzo. I am the Chief Executive Officer of the Global Foot and Mouth Disease Research Alliance. And this time I would like to welcome all of you to this meeting organized together between the GFRA, the European Commission for Foot and Mouth Disease, and the OIE. This is the second meeting we do, a regional meeting that we do together. We have first had our meeting in America that was a real success, and I know today it will be a success as well. Today you are going to go through vaccination and new vaccines and also currently used vaccines and how to measure protection. So I think you will really enjoy this meeting. So please get ready and follow us because if you do FMD research, you have to be part of the GFRA.
Thank you very much. I mean, unfortunately, Alejandra will still be in bed because it's quite early morning still there. And I need to now share a screen, and that's not always so easy for some of us. So just bear with me. Okay, can somebody just tell me if we're seeing the right screen?
You're still seeing you, Wilna.
You're not seeing a screen? Oh, what have I done wrong? We've practiced this. Oh, okay. Ta-da, ta-da.
Now something is. Now we see your screen.
We're making progress. So we just need to have the slideshow start. And it's the wrong one. Or is it the right one, Kies?
The wrong one. Well, it's the right presentation, but it's a present. Well, now it's okay.
Yes, finally. Right. So as I say, today we are looking at vaccination against foot and mouth disease, principles and practice. And we actually had 368 registrations from 63 countries all over the world. So it's really a very well represented workshop, and we're really grateful to see the interest in attending something that I think is close to all of our hearts, and that is how to use vaccination in the sort of Asia area where we are located. So I want to just start off by thanking all the organizers. So we have organizers from the GFRA, myself, Nagendra Singanallur, and Alejandra, who we've just seen. And then from EuFMD, a great thanks to Nadia Rumich, Fabrizio Rosso, Alessandra Alfiti, Ludovica Nela, Costanza De Laurentiis. Thank you very much for your help and assistance in this workshop. And then we also have the moderators who will be helping us with the workshop or the roundtable discussion that we have towards the end. And that is Kies van Manen and Theo Knight-Jones. And then we have our two very able rapporteurs, Nagendra Singanallur and Petrus Janssen van Vuren, who will be working very hard in the background to write down your questions. And also we will write up a report after this meeting. So just a little bit about the Global Foot and Mouth Disease Research Alliance. Together with the EuFMD, we are the leading organizations networking on foot and mouth disease research and control all over the world. And we have our websites, which you are welcome to visit to get a little bit more information. So what the GFRA has done over the last few years is to do quite a few gap analyses where we were looking at what are the research gaps which we can address to then help in progress the control of foot-and-mouth disease globally. So these are available on our websites. We are also working on an e-book that will be available shortly in Frontiers of Veterinary Science, which will contain a lot of the work that's being conducted within the GFRA network. We also hand out a newsletter once or twice a year, which is more of a sort of a friendly, non-scientific way of informing everyone what we do. And these are also available on our website. And then we sort of, with EuFMD, we've decided that GFRA will host a scientific meeting one year, and in the next year, the EuFMD hosts their regular open session. And the good news is that this year is the GFRA meeting, which will be in later in this year. And so just want to tell you that please save the date, that our meeting will be between 1 and 3 November in Buenos Aires, and the lovely Alejandra will be hosting that meeting with the team that she has in Buenos Aires. So with that, and if I'm lucky, I can be able to stop sharing, and I'm going to then hand over to Fabrizio, who will just welcome us on behalf of EuFMD.
Thank you very much, Wilna. Good day, everyone. I'm very glad that with the joint collaboration between the Global FMD Research Alliance and the EuFMD, we managed to organize this regional meeting for Asia and Southeast Asia, overcoming, I should say, the difficulties we have for meeting in person in this COVID time. And I hope we can also use this period to identify new ways to enhance the network between scientists and experts that we can use beyond this difficult period. The meeting has been organized in connection with, as you said, with the recent EuFMD open session, where also issues related to the availability of quality vaccines for emergency response and the evaluation of vaccine efficacy were discussed in live sessions and posters presented. And I'm pleased to see that the topics in the agenda of this meeting that will be presented by relevant speakers are very much complementary to the open session. And in fact, is relevant issues, as in many strategies for controlling FMD and similar transboundary animal diseases, a significant proportion of the resources in terms of money, time, and human resources is allocated to vaccination. But by contrast, insufficient resources are usually set for monitoring and evaluation of vaccine quality and effectiveness of vaccination program. And I believe there are some opportunities also included in our work program to help addressing some of the issues. So initiatives aim at improving countries' capacities through trainings, meetings such as this one, and backstop support to countries, but also, for example, the establishment of regional expert groups for vaccination advice, guidelines, and consultation that can guide at regional level the implementation of immunogenicity studies and assist the interpretation and dissemination of results, or provide advice on the use of vaccines in the region. And I believe it is equally relevant to establish a multi-stakeholder platform for vaccine security, to develop a common approach and actions towards the improved availability of quality vaccines with greater engagement of the private sector. And in this regard, encourage and support the work for a robust quantifications of the size of market demand for FMD vaccines that can support a long-term investment decisions by the private sector. And finally, I also would like to mention the importance of establishing procedures to accelerate the procurement of vaccines in emergency situations, ensuring emergency supply of vaccines with appropriate high quality, safety, and efficacy. And I hope that some of these issues will be, I'm sure that some of these issues will be covered during this meeting. And I think also that the COVID brought to the attention to the international community issues that we face regularly in FMD control and response strategies. For example, on how to prioritize resources, how to streamline the availability of vaccines, ensuring safety and efficacy, as I said, on how to ensure business continuity during crisis, and the importance of having a global surveillance for antigenic characterization of new lineages. So with these few words, I leave you to this session. And Wilna, you have already thanked the EuFMD staff who have worked and assisted in that. And I would like really to thank you and Nagendra for having organized this event together with the EuFMD. Thank you and have a good meeting.
Thank you so much, Fabrizio. And it's really just been a pleasure to work together. And I hope that it's the start of many more such workshops. So I'm going to hand over now to Runello Abila, who is and Runello, sorry, I can never remember exactly your title, but leading the Southeast Asia China foot and mouth disease group in the sub-region based in Thailand.
Thank you, Wilna, and a pleasant good morning, good afternoon, good evening to all the participants. I know we have, as shown by Wilna, we are now all over the globe. So many participants watching this webinar. It's really timely, these topics that has been chosen by GFRA. I would like to really congratulate GFRA with Wilna and Nagendra, who were the key persons who are behind in organizing, and of course with the support of EuFMD and other partners who have supported this in organizing this scientific webinar. The presentations this afternoon is very timely, particularly for our region in Asia and Southeast Asia and all those endemic countries that still rely on vaccines to control FMD. The CCFMD, the Southeast Asia and China FMD campaign, which we started quite a long time in 1997. We really have a lot of experiences to prove that with the use of quality, high-potent vaccine, it can really control FMD. We had some pilot studies in the northern Laos, in central Myanmar, in some other areas, some pilot areas also in Cambodia and in Vietnam. And experiences coming from other members of the CCFMD has shown that using a quality potent vaccines can really reduce and prevent FMD outbreaks. But still, we encounter a lot of problems of our members encountering outbreaks in spite of the vaccination. So what's really the problem? And one of these is really the use of vaccines which don't have the proper quality. And I have heard some farmers in our region that they even try to vaccinate 3 times a year just to make sure that their animals are protected, and yet they still experience outbreaks. So it's now going to the issue of possibly the quality of the vaccines, or maybe in the application of the vaccines. So these are issues that we have to look at. So it's really a big challenge for countries that still encountering outbreaks, particularly those who are vaccinating and encountering outbreak, to really review, assess the vaccines that they are using, and also the process on the implementation of the vaccinations. The presentation this afternoon will provide really a strong science on the importance of how to look at, to do an assessment of the vaccines that is being used by the different countries. And for the OIE CCFMD, in our new roadmap 2021 to 2025, this is one of our priority, to really provide to our members access to a quality vaccines. There are other issues, not only on the technical aspect, but also other issues like legislation, regulations, how governments really regulate in the movement or the distributions of vaccines, or countries or a private sector who would like to access new vaccine, particularly if they are challenged by new emergencies and they would know they would need new vaccines with to protect against the new strains, they might be challenged with all these regulations. So these different challenges we are looking at on how to overcome this. So one of the first steps that we will be doing, we will be coming up with a study with the help possibly of a consultant, if possible within the year. In the first year in the implementation of the new CCFMD roadmap, we will conduct a survey looking at what are the constraints, what are the gaps in the access and implementation in the use of quality vaccine in the region. So we can really provide guidance to the countries that they could have access of quality vaccines and be able to properly implement vaccinations. So with that, we would be, of course, continue to partner with GFRA, with the experience of EuFMD, which has been existing for quite a long time and has a lot of experience, and with all the other institutions, collaborating centers in the region, the OIE collaborating reference centers in the region, the experts on FMD, and also the different FMD control managers who are here to work with you in the coming months and years in order to be effective in the implementation of FMD control in Southeast Asia, China, and Mongolia, and also in the rest of Asia. Again, I look forward for a very successful meeting that we have. Thank you.
Thank you, Ronel. And hopefully some of the talks today and the roundtable discussion will help us address some of the issues that you've raised there, which is not only applicable to Southeast Asia, but many other areas, endemic areas as well. So I'm now going to hand over to Nagendra, who is going to chair the rest the session until we have the break. And while Nagendra is switching on his camera, I'd just like to introduce him as a veterinarian that is working as a senior research scientist at the CSIRO Australian Centre for Disease Preparedness here in Geelong. And for the past 20 years, his research has focused on foot-and-mouth disease vaccine development, quality control of vaccines, and vaccine evaluation in laboratory and field conditions. He's involved in all the FMD-related projects at the ACDP where we are working, involved in the training and capacity building in Southeast Asia since 2011. And he is currently serving as a member of the GFRA Executive Committee and the joint OIE FAO Foot and Mouth Disease Expert Group for CCFMD. Thank you, Nagendra, and I'm going to hand over to you now.
Thank you, Vilna. Hope everybody can hear me. The first talk for today is from Dr. David Payton. Dr. David James Payton is a veterinarian who is working part-time with the Purbright Institute in the United Kingdom. He's a well-known international consultant and expert providing knowledge on surveillance, vaccination strategies, and research to control transboundary livestock viral diseases, especially foot and mouth disease. He was the co-author of an FAO OIE guidelines on FMD vaccination and post-vaccination monitoring. Dr. Payton works on projects to improve serological evaluation of vaccines, amongst other many things that he does for the OIE and the FAO. Dr. Payton, the floor is yours. Thank you.
Thanks very much, Nagendra. Hello, everybody. And I'm joining you from an unusually sunny and pleasant spring morning in the UK. So my talk is entitled Serological Monitoring of Foot-and-Mouth Disease Vaccination, Principles and Practice. And I'm going to talk a little bit about the attributes and interpretation of serological tests for population immunity studies. And a lot of my talk will be to go over with you what we know and don't know about the correlation between antibodies and protection and in the way that we can measure them. So if we think about post-vaccination monitoring by serology, Ronello's already advocated the importance of this and the fact that it's sometimes neglected. Up at the top of the screen here, there is just a reminder of the front page of this guideline that has been produced by FAO and OIE on foot and mouth disease post-vaccination monitoring. So that's a useful reference. So well, why do we need post-vaccination monitoring? Well, the reason is because vaccination for foot and mouth disease can be extremely effective, but it doesn't always work out as planned. And in fact, it's quite a complicated logistical program to do it usually. And there are things that go wrong, so we need to find out. And it's a good idea, therefore, to check the implementation of the vaccination and make sure it's been done well. You can, of course, also, and you should, of course, also look at the outcomes of vaccination. So you should be looking to see whether it's actually stopping outbreaks, whether it's preventing infection through NSP surveys and the like. But an advantage to monitoring population immunity is that you can actually find out if there is a problem with the vaccination before the disease arrives. So it is an important cornerstone, I think, of monitoring your vaccination. Although it will certainly help to tell you if you have a problem with your vaccine, I've said here at the top that it's not primarily to find out if the vaccine is suitable, in my opinion, because really you should do that before you start to use vaccine on a large scale. So I would say it's more to check on the logistics, the cold chain, the fact that you've vaccinated all the animals. So I said that a lot of this talk is about the correlation between antibody and protection, but in fact, you can also interpret post-vaccination monitoring population immunity surveys in another way, which is you can ask the question, have enough of your animals been correctly vaccinated? So if you know, for instance, that your vaccine is a very good one, and you have done a proper job to make sure that it works well, and then if you know a lot about the vaccine and the serological response that you can expect from that vaccine, then in fact you can use your surveys in the field to find out if you've had those expected antibody responses. So that's actually not about protection per se. But in addition to that, people usually do want to try to interpret population immunity studies to find out whether they have enough antibody to the field strains, to the particular strains, and to try to predict whether they will be protected. And finally, for this slide, you can, of course, do vaccination population immunity studies at different stages of the vaccination cycle. So after vaccination, it takes time for antibody to build up, and then you get a plateau, and then it starts to decline, and you have to give a booster again, maybe in 6 months' time for foot and mouth disease vaccines. So it's possible, in principle, to do the population immunity surveys at the time of peak immunity or at the time of revaccination to look at whether you have had sufficient duration of immunity in the intervaccination period. So the principle, of course, is relatively straightforward, that foot and mouth disease vaccines induce antibodies to viral structural proteins, and we know that these are an important component of protection. So the presence of these antibodies can be used as an indicator of successful vaccination and probability of protection. So it all sounds quite straightforward at first sight anyway. But the big question is how much antibody is actually needed for protection. Before diving into all the detail, I think we can make a general point that in fact, for foot and mouth disease, as for most viruses, you don't actually need very much antibody on the whole to have some protection, as long as it's the right antibody that is directed against the strains that you need to protect against. But in terms of trying to understand the correlation between antibody and protection, this is mainly based on vaccine potency tests. So these are the tests that are done when new vaccines are developed for registration purposes, and the vaccines have to have proven efficacy, and you have to know the potency of the vaccines. So this is done by vaccinating target animals, which are usually cattle, according to a set standard protocol with a standard challenge with foot and mouth disease, live foot and mouth disease virus, at a set period and by a set route. And if you look at the antibody levels at the point of challenge, and you can compare them to the clinical outcome, whether you have protection or not, and then you can work out a correlation between antibody levels and protection. And for these types of study, nearly always the two tests that have been used are the virus neutralization test or the liquid phase blocking ELISA. And the reason why these tests are very suitable for this is that it's possible to change the virus in the test relatively easily, quite easily in the case of virus neutralization test, with more difficulty for the liquid phase blocking ELISA, but you can tailor the virus to the situation. And in fact, what is done is in these challenges is that we use what we call a homologous test system. So it's the same virus is used throughout. So the same virus is in the vaccine as is in the challenge, as is in the test. So it's an entirely homologous system. Anyway, because quite a lot of these homologous challenges are done to register new vaccines, we know quite a lot about the serological prediction of protection under these rather specific circumstances. And here is an example of a study which has brought together the results of multiple potency challenge tests, tried to average out the differences that you get in individual animal variation, and draw some general conclusions about what is the relationship between serology and protection. So this study has been done with several different serotypes. It's been done using the virus neutralization test. And if you look at the figure in the middle, you can see that there is a straight line association between probability of protection and antibody titer, log antibody titer, over most of the protection. So there clearly is a strong association between the two. And you can, if you look, you see there is this family of curves with different lines for different serotypes. So although they all have a similar relationship, it's not exactly the same. And the amount of protection you will get for a given amount of antibody differs between the serotypes. And this can also differ between strains. So once you have established that there is a correlation between antibody and protection for your vaccine, this is also very useful from a point of view of controlling the quality of the vaccine for subsequent batch release, because when you make different batches of vaccines, you want to know that they're as good as the initial one that you had made. And so what this means is that when you produce new batches of vaccine, the manufacturer can do an immunogenicity trial without a challenge, and he can look at the antibodies and where they lie on this curve. So if he wants, for instance, to have a 75% probability of protection with a type O virus, he can go along and see that you will need to have an average antibody response in the animals of around log 10 1.7 or 1 in 56. And in principle, you can use the same thresholds in your population immunity studies. And this is indeed the basis upon which many people select the cutoffs for their population immunity studies. But there are certain caveats that one needs to be aware of. So the first and rather important one is that for foot and mouth disease, we know that antigenic variation is very important between strains and can affect the degree of protection or cross protection. And the systems that I've talked about have all been based on homologous challenges and homologous test viruses. So not so many cross protection studies are done as for homologous challenge, but there has been some research on the subject. And this is a paper here from Germany in 2008 that did a series of cross protection challenges in cattle with serotype A foot and mouth disease viruses. And what, again, you can see here from this curve is that there is still, you can find a correlation, a good correlation between the VN theta, the log VN theta, and the log potency of the the vaccine, as long as you now substitute in your virus neutralization test the challenge strain rather than the homologous vaccine strain. So the homologous vaccine strain, if you put that into your test, you won't get a good correlation because of the lack of antigenic relationship. But if you use the challenge strain, then this can help deal with this problem. So one option for you is, if you have the field strains that you want protection for, you can put them into your test, something like the VNT or perhaps the liquid phase blocking ELISA, and use them for your population immunity studies. But the problem is that neither the VNT is not very suitable for survey work on a large scale, and the liquid phase blocking ELISA is not readily available as a commercial assay. So what are some other difficulties to do with correlating to serology to protection from potency tests? So one thing you have to think about is the timing after vaccination, because of course the potency tests are always done at 3 to 4 weeks. The challenge is 3 to 4 weeks after vaccination, but in the field, of course, they can occur at any time. And we have already said that you might wish to also look at duration of immunity rather than peak immunity with your population immunity studies. But you have to be aware that if you measure antibodies at times other than 3 to 4 weeks after vaccination, we don't really know very well how well the levels of antibody correlate with protection, because hardly any studies have been done. And we would expect on theoretical grounds that it certainly might not be the same. So another issue then is that I've mentioned is the problem of these ELISA kits, because most of the kits that are available to buy commercially for SP serology, these are solid phase competition ELISA tests, these have not been very well validated for correlation with protection. And it's difficult to do this because they have a particular virus strain in them that is provided by the manufacturer. And we will be uncertain of the relationship of this to both the vaccine virus and to the field strains that you want protection against. And another point just to mention is, of course, that the required protection that we may want to measure in the field may be different from that of a challenge potency test, but I haven't really time to go into that now. And of course, another difference in the field will be that animals will have received different numbers of doses of vaccine compared to that of a straightforward challenge test. So there are some complications in extrapolating correlations from potency tests to field use. So, okay, then to finish, just to go through a couple of slides that give an idea of where you might be in a particular field situation and how you can try to navigate through some of these issues. So I would say in an ideal situation, if you want to do a population immunity study, you would be using a vaccine and chosen regime that induces a consistent and well-characterized serological response. So you know a lot about how the potency, match, and duration relates to the serological response. So the more you know about the vaccine and what to expect of it, the better able you are, of course, to do these studies. The second point is it's very useful if you can have available the latest field strains and some vaccine batch release sera. I mentioned that these immunogenicity tests are done by the manufacturers, and so they have these sera and they may be able to release some to you. So with these two things, they can be very helpful to establish protective cutoffs against field strains using virus neutralization tests. And you can also help to try to cross-calibrate then between the commercial ELISAs that you might want to use in the survey, and that could help you for that. A third thing that you can do, which is very beneficial, is you can try to do some small longitudinal studies in your own country to chart the waxing and waning of antibody with your chosen vaccine and vaccination regime and your chosen test system. And if you do this in relatively controlled conditions, you then have a very good idea of what to expect from your population immunity studies. So if you manage to achieve all this, I think there is a good chance that you can know what test serology results to expect throughout vaccination, and you can probably also infer something about the likelihood of protection. If you contrast that with a more compromised situation, which some people are in, which is perhaps they are using vaccines that are inconsistent, they frequently change the ones that they use, and they're not very well characterized, and they don't really know much about what to expect in terms of serological responses or test reactivity. Possibly people in this situation are relying entirely on commercial ELISAs without information about the levels of antibody to expect or what will protect. In this situation, it's probably better to focus on testing animals at a month after vaccination and to send some sera to a reference laboratory for more analysis, so they may be able to help you with the calibration of your ELISAs. I think you can still do a lot, however, even in this situation. So it's by no means makes it not worthwhile to do population immunity studies, because you can compare immunity between different subpopulations and vaccination regimes. And if you do detect antibody, its presence is likely to be still indicative of some protection. And I think it's surprising, in fact, how much you can get from these sort of studies if they're done in a systematic way, and you will certainly be able to still see some very useful trends. So my conclusion is that despite uncertainties, population immunity surveys are very useful. In fact, I would say essential to monitor the implementation and effectiveness of vaccination. There are various ways to set test thresholds when measuring population immunity, and this will depend on what you know and can actually do. However, you usually have to make assumptions due to incomplete information, and therefore it's important to understand the limitation of immunity estimates. And finally, if you want precision, you do need to do a bit of work. You will need a close cooperation with your vaccine producer and regional reference lab, and you may have to do some small studies of your own. So I'd just like to finish with cross-referencing again to this post-vaccination monitoring guideline, which has a lot of the principles of doing these things practically in the field. And complementary to that is perhaps this paper, which has more about the principles in the lab. And with that, I will finish. Thank you very much for your attention.
Thank you, David, for a nice presentation. Our next speaker is Dr. Anna Ludi. Anna is a member of the Vesicular Disease Reference Laboratories Group, which encompasses the FAO World Reference Laboratory for Foot and Mouth Disease, the WRL for FMD, and the OIE Regional Reference Lab for FMD. Dr. Ludi has a bachelor's degree in biotechnology from the Rocha Institute of Technology and a veterinary degree from Cummings School of Veterinary Medicine, one of my favorite universities, Tufts University in the USA, followed by a PhD from the University of Cambridge. Her interests are antigenic variability of foot and mouth disease virus, vaccine matching, validation of serological assays, and post-vaccination monitoring. She and her team carries out serological work for Fmd virus, swine vesicular disease virus, and vesicular stomatitis virus. The serological tests are used for importation and exportation of livestock to assist with post-vaccination monitoring and vaccine selection. Her group also carries out annual proficiency testing scheme, one of the important schemes operated by the WRL on FMD. Dr. Ludi, the floor is yours. Thank you.
Thank you so much. And hopefully you can see my screen and you can also hear me. Thanks for the introduction. As said, my name's Anna Ludi and I work within the World Reference Laboratory. This work is done by a lot of people at the moment within the WRL. So I've just mentioned them here, and I've also put my email address in case anyone wants to get in touch with me after the talk. So my presentation today is a new model for independent FMDV vaccine QA/QC as an aid to vaccine selection. And I think it follows on really nicely from David Payton, presentation about what can be done in regards to determining what vaccine can be used in the region. With the audience that's present today, I don't think I have to go into too much detail about what R1 values are or relationship coefficients, but just as a reminder, R1 values is a measure of antigenic relatedness between a vaccine virus and a field virus strain. And it's the antibody titer of a vaccine serum against the field isolate divided by an antibody titer of a vaccine serum against a vaccine strain. Anything equal to or greater than 0.3 indicates that there's a close antigenic relationship between the field isolate and the vaccine strain. And again, this is the test that my lab produces, a lot of this value, and I'm sure you've all seen our reports. And it is one way that we try to get a bit more idea about how the vaccine does with the field. I think a question that comes up a lot, and a question that has been talked about at many other meetings and various discussions throughout the years, is whether or not these R1 values are actually useful. So in my opinion, they are. And there are many examples where they have been useful. And one of those will be discussed actually later on today by Wilna. But these type this type of information is useful. And one such example is the O1 Manissa vaccine against the O India 2001 lineage, where the R1 value ranged kind of around the borderline, to be honest, between 0.12 to 0.43. And we weren't quite sure whether or not this vaccine was suitable for the India 2001. We were then lucky enough to carry out an in vivo study, and we found that the heterologous potency was around 3.5 PD50, which again is okay. Of course, we can't talk about R1 values without talking about the variation. And this is some work that was done by Jamalia a couple of years ago now, in which she tested different types of bovine vaccinal serums against a certain strain from Malaysia and generated R1 values. So along the x-axis here, you have different days post-vaccination, and along the y-axis, you have the R1 value, and each one of these diamond shapes is a different animals. And what you can see here really is the R1 values are all over the place, and it's really difficult to know what the R1 value actually is. And it really highlighted to us that the bovine vaccinal serum that's needed for this test needs to be standardized. And so that's what we've done, and this is kind of the definition that we use when we generate bovine vaccinal serum for R1 values. So it has to be a high potency vaccine. We want a monovalent vaccine, so that's one strain of FMDB, 21 days post-vaccination, a single vaccine, so no booster, and it's done in cattle, and we always pull together 5 cattle. However, vaccine used in the field is different and is dependent on the country's vaccine regime. And there's a lot of reasons why it's different, such as the fact that it's sourced from different manufacturers. Usually animals receive multiple vaccinations. It might be used in pigs. It's polyvalent, et cetera, and the list can go on. So a couple of years ago now, we were asked or invited to an OIE twinning project with EuFMD to look at what can be done to increase the quality of vaccines in Africa. And this is really where this new model comes in. So what are the challenges in Africa? And again, some of these are a bit similar to Asia, but you will see some differences as I walk through these. So Fmd viruses in Africa are antigenically diverse, and the vaccine used are of variable quality. And we have had reports from the field and from government officials that actually there are vaccine failures, and there's really a lack of data to support any one of the vaccines that's being used. EuFMD is actually mandated to provide independent quality control for all veterinary vaccines for Africa, but at the moment, they don't have the ability to do that for FMD. So our goal was to establish and embed a new tool define whether vaccines are suitable for use in different endemic pools in Africa. And so the model that I'm going to be describing today is specific for Africa, but again, it can be used for it can be applied to different regions such as Asia. Our starting point for all of this was to really figure out who is responsible for what. So what are the vaccine companies responsible for? What is the customer responsible for? What is the OIE, FAO, FMD lab network responsible for? And then where does EuPanVac fit into all of this? And we really used two different literatures for this. So we used the vaccine QA/QC from the OIE, as well as this post-vaccination monitoring guidelines that David talked about in his talk as well. And then we really went through and just listed the various things. And due to time, I'm not going to go into great details, but again, we kind of highlighted who would do what in this panel and where we would fit in with the OIE twinning project. And again, excuse me, this is specific for EuPanVac and for Africa. And of course, if it was used somewhere else, these things would need to be updated. We were also very, very lucky in this study that we had the collaboration of 3 vaccine companies that helped us throughout this entire study. So what was the project vision and what was our testing framework? To look at all of these things. And there were really 3 parts, and I will go into each one of these in a bit more detail as I go through my presentation. For the first thing was to generate a representative viral panel for Africa. And this was really the key main step that we started with. We then also generated lots of reference serum. And again, this is where the vaccine producers came in and kindly generated their vaccines to be able to do this. And then lastly, we looked at what type of tests would be used in order to continue, in order for EuPanVac to continue to carry out this type of quality assurance as time goes on. And unfortunately, I don't have time today, sorry, my slides keep skipping on me, to go into too much detail on this, but it is definitely something that you will hear in the future with various other talks and meetings. And it is something that actually we're still currently working on. So for us, it was very important that this representative viral panel was agreed not only by us and what we felt in the project, but also by a much larger network. And that was the OIE, FAO, FMD lab network. And the reason for that is that we needed to have agreement that, yes, this is a representative panel for Africa. And this was extremely important for this project because here we are not looking at homologous titers, so titers using the same strains that are in the vaccine, but we're actually only looking at heterologous titers. So how well does the vaccine work against viral lineages that pose a threat to the region? And this was very important to us. So this panel is what we will test all of the vaccines against. And we do not look at the vaccine virus. So we don't need the vaccine virus from the vaccine companies, which of course is one of the difficulties that we face when we carry out our R1 values. So how did we do this and how did this all start? Well, at the World Reference Lab, we're of course very lucky to receive samples from all over the world, including Africa. So we looked at the sequences that we had available. Here on the right, you can just see a map and you can see, of course, that there are certain gaps, but we did the best that we could. We then tested these strains against the VNT to come up with an antigen panel. And then we narrowed it down because, of course, we didn't want to have too large of a panel. And to start with, we did 4 isolates per serotype for East Africa. And so if you look at the phylogenetic tree, they look something like this. So you have O here on the left, followed by A, SAT1 and SAT2, and each one of these little dots represented one of the represented reference panel strains that we wanted to use. And you can actually see that there's a lot of strains here. And to be honest, we haven't tested all of these through our virus neutralization test, and it's not clear at this point whether or not we will need to. So what does it look like when we put these into the virus neutralization test? So this is just an example of 4 serotype O strains. On the x-axis here, you have individual monovalent, very well characterized serotype O serum that we have available at the World Reference Lab. Along the y-axis, you have the neutralization titers. And so you can start looking at these type of profiles and say, well, actually, strain D and strain A behave very differently. And those are probably 2 that should be included in the reference panel. So the next step was to look and to make a reference serum. So for us, that was well-characterized bulk serum that can be used as a standard deviation between laboratories and industry. And by bulk serum, I mean that we terminally bled these cattle. And so we were able to get about, oh goodness, close to 2 liters of serum for each of the animals. So this is the type of reagent that will last for a very, very long time and that we can easily share between different partners. And there's really 2 reasons to do this. One, it does help to identify the antigenic relationship when choosing the reference panel. But 2, it also helps to calibrate and harmonize assays between laboratories so that we're all using the same reagents and we're all using the same controls. And therefore, we can have more confidence that when we share results, we're actually measuring and looking at the same thing. So how does this all work? And this is just one example. And again, for Asia, you'd have to think about whether or not there's certain things that you would want to change or well, dependent on the situation that you're in. So for us, it was very important to use the formulated vaccine that is used in the field. So this is not an experimental batch from the vaccine. This is not a monovalent high potency type of vaccine that would be used to generate BVS4R1 values. This is what's being used in the field. So this is going to be your polyvalent multi-serotype vaccine that could be 3PD50, that could be 6PD50, whatever it might be. We know, obviously, there's always limitation on the number of cattle that you can use for these type of experiments. And there's really, you know, for ethical reasons, of course, we don't want to use lots and lots of cattle. So for us, we actually only used 5 naive cattle for each one of these tests that we've done so far. And for us, we felt that we saw the difference that we need for the animal-to-animal variation. And then, unlike the R1 values, we don't just collect serum at 21 days post-vaccination, but instead we actually look at the vaccine regime that is currently being used and collect serum based on that. So that means that we don't always, well, of course, we collect blood at day 0, but we may also collect blood at the booster vaccination, if that is important to your plans to vaccinate in the field. And again, you could say, well, actually, I'm really interested to know that I still receive good vaccine levels 6 months, a year down the line. Well, of course, with this method, you could then collect serum that far down the line, and again, test it to see whether or not you're still getting the antibody levels that are appropriate. So to end with, I'm really just going to spend a little bit of time talking about one vaccine that we have tested. And I do realize it's SATs, which aren't in Asia, but I still think it highlights the point of how this all fits together and how we've been using this. So this was a vaccine that we tested. It contained both SAT1 and SAT2. On the y-axis, you again have the neutralization titers that were obtained by VNT. And along the x-axis here, you have the 4 reference strains that were chosen for SAT2 and the 4 reference strains that were chosen for SAT1. Each one of these bars here represents a different animal. So you can see that we vaccinated 5 animals in total with this SAT1, SAT2 vaccine. Now, everyone is kind of always keen to draw some kind of line here as to what is a cutoff for this type of test. So arbitrarily, we chose the test of 1.5, and of course we could have an entire other presentation on why that was chosen. But I should mention that this is not the cutoff that should be used for protection. It is specifically used for this OIE twinning project and as part of another competition that's currently going on in the region. So if we look at this, you'd probably go, well, you know what? The SAT2 actually isn't that great. There's a lot of animals here, maybe 3 out of the 5 animals that are actually below this 1.5 cutoff. And here it's even worse, really, with only 1 just hitting it. Maybe you'd say, well, the SAT1 might be slightly better, but again, this Tanzania 22, 2013, I don't really have any protection against that. And I think you might wrongly say, well, actually, I don't want to use this vaccine. But what you have to remember is that this is actually 21 days post-vaccination. And as per recommendation from this vaccine company, you would actually booster this vaccine. So if you were to actually booster at 21 days, and then you look at the results 10 days post-booster, you can now see that actually you have really nice antibody responses for all of the strain and for all of the animals. I mean, maybe you could argue that this one's a little bit low, but again, for the majority of these, this is really nice. And if you would see this type of data, you'd probably say, well, yes, that vaccine will work in my region where these 4 strains are a threat if I booster. And so this is really the type of work that we're now taking forward. And with that, I would like to thank you for your attention. And of course, I will take any questions at the end. Thank you very much.
Thank you, Anna, for the very comprehensive presentation. Before we go into speaker number 3, I would like to announce attendees, you can please put your questions on the chat box, which will be answered at the end of the session during the panel discussions. We welcome more questions, any type of questions that you have on FMD vaccination, post-vaccine monitoring, and quality control of vaccines. Thank you. Our third presenter is Dr. Wilhelm Wassler, who is a Senior Principal Research Scientist at the CSIRO Australian Centre for Disease Preparedness here in Down Under Geelong. For the past 30 years, her research has focused on transboundary animal diseases, especially foot and mouth disease, that not only has the potential to infect livestock species, but have wildlife maintenance host that makes the control of the disease very complex and eradication near impossible. Currently, she is responsible for the FMD research program at the Australian Centre for Disease Preparedness. Wilhelm serves on the OIE FMD ad hoc group as a member of the Southern African Centre for Infectious Disease Surveillance Scientific Board, and also serves as the Vaccine Expert Advisory Group member in Australia that provides guidance on decisions regarding the Australian FMD Vaccine Bank. Wilhelm has also been part of the GFRA Executive Committee since 2013 and also served as the CEO for the past 5 years. Wilhelm, take it away.
Thanks, Nikendra. And hopefully I have better success this time in my screen sharing. So I'm going to pose the difficult question around in vivo testing of vaccines in Southeast Asia and the difficulty of how well do the antigen matching actually correlate with protection. So we know, and again, this is just a little bit of brief background, large parts of the world are disease-free, and all the countries in green here have status either disease-free with vaccination or without vaccination. But there are large parts of the world where the disease is still endemic, and these areas are quite often the source of infection to free countries, but also the source of infection to each other, with viruses moving into areas that they previously haven't been. So to try and address the control effort, I mean, everyone in the foot and mouth world is very familiar with the pools of viruses where the viruses have been divided into geographic pools to make control a bit easier, where you have viruses that are similar in serotype and in genotype and topotype, where you can then make a recommendation on what vaccine to use or what reagent should be used in a diagnostic assay to ensure that you have a good result. So the potential trans-pool movements between these different pools warrant us to continually monitor what is going on and so improve our surveillance globally. So for example, and this is just a few of the examples, it's not all of them. Recently, we have had the so-called India 2001 strains that have moved in an east and westward movement from South Asia. And similarly from South Asia, we had a new lineage called the AG7 that moved from South Asia in a westwards direction. And we also had the Myanmar 98 lineage that emerged in Southeast Asia and spread in an easterly and northerly direction. So of course, we need to continuously know what is happening in the world, what are the circulating strains to assist us with our preparedness. As I've mentioned, maybe do we have to update our vaccines or do we have to update our diagnostic assays? So Anna has already told you about the R1 values and how we interpret those R1 values. And she's also showed you that the R1 values are highly variable and quite difficult to use as a prediction for protection, but it's still very useful in giving us some guidance on whether vaccines will protect or not. One of the other aspects I just want to highlight is how we determine how potent a vaccine will be. So there are basically two methodologies that is in use to determine homologous vaccine potency. And one is called the protective dose test, or the PD50, which is the dose of vaccine that will protect 50% of the animals. It's done in a sort of a titration way where animals are given different doses of vaccine, normally a full dose, a quarter dose, and a 16th dose. And it's generally accepted that a 3 PD50 per dose vaccine is acceptable for routine vaccination, whereas a 6 PD50 dose vaccine is used for emergency vaccination. And for most vaccine banks, it's also the amount of antigen that will, or the potency that will go into a vaccine. We also have what is called the protection against podal generalization test, or the PPG. And in this test, you have 16 animals that are then vaccinated with a single dose of vaccine and challenged. And if 75% or more of the animals are protected, this vaccine is accepted as an acceptable vaccine. The one problem that we are dealing with is that there are actually limited numbers of commercial vaccine strains available. And some of these vaccine strains are only used in certain geographic areas, making the pool of generally available vaccine strains even smaller. We know that foot-and-mouth disease virus is constantly evolving and changing, and that there's been antigenic drift noticed over the last 30 years or so. Whereas Anna showed you the R1 values that are, or the vaccine matching that is very useful predicting homologous protection, we don't always know how to interpret these data when we are looking at heterologous protection. So in that instance, we see that live animal challenge is still seen as sort of a gold standard. So if you really want to be sure that the vaccine will work, this is the way to go forward. The only problem is that, of course, live animal challenges are expensive. And there's also an ethical question around, whether we should be doing that type of tests. So I want to just highlight one specific example here where we have been looking at a new emerging threat that didn't spread into Southeast Asia, but it was certainly of concern, seeing that the India 2001 lineage had spread into Southeast Asia. So the AG7 virus, it spread into a westward direction, And it was shown that the vaccines in the field were not providing the protection that was expected. And also the in vitro vaccine matching data showed that this new field virus matched very poorly to viruses being used in Eurasia and Southeast Asia. So of course, this was a red flag to not only the endemic countries, but also the foot and mouth disease-free countries. So based on the work that was published by Waters et al., we calculated the geometric means of the R1 values, and they were all below the 0.3 level of expected protection. So A22 Iraq 0.1, A Malaysia 97, and you can see the values there, all below the 0.3 that we're always concerned about. So the Waters et al. Paper that I'm referring to, they performed the PGP with a commercially available polyvalent vaccine that had different serotypes included in the vaccine, but for serotype A, it contained the A Saudi 95 and A Iran 05 vaccine strains. And in this test, they found about a 56% protection. And as I said before, 75% is normally the acceptable range. Therefore, this vaccine seemed to be not as effective against this G7 strain. So together with our collaborators at ID Lelystad, we then decided to look at the A Malaysia 97 and A22 Iraq monovalent vaccines, which will be used in an emergency situation. So these vaccines all contained greater than 6 PD50 per dose. So we first did a small experiment where we vaccinated and challenged 7 animals with the 2 different monovalent vaccines. And we found that the A Malaysia 97 vaccine actually provided pretty good protection, 72% protection that equated to about a 3 PD50 per dose. We also saw a reduction in virus shedding and a good correlation between the VN titers and protection. So we then decided to continue with the A Malaysia 97 vaccine strain and do a full potency test where we do the titration of the virus in the different animal groups. And the results of that was that the A Malaysia had a PD50 of about 6.5. And this is despite the fact that the R1 value was around 0.2. So just indicating that if you have a good quality, high potent vaccine, you can get protection against the heterologous challenge, even if the R1 value seems to be sort of suggesting that the vaccine may not work. So this brings me a little bit into broadly protective vaccine strains. So one of the strains that our colleagues and collaborators in South Korea have been working on is the O1 Campos vaccine strain, which belongs to the Euro-South America topotypovirus, which is completely or very, very unrelated to the viruses that are circulating in South Korea. So for example, if one looks here at the VP1 nucleotide percentage differences, there was quite a big difference between O1 Campos and the OSKR vaccine strain. They also looked at the one of the Russian vaccine strains, O Primorsky, and surprisingly enough, despite the genetic difference between the viruses, O1 Campos actually provided an R1 value of above 0.3, indicating that this vaccine strain is likely to work. So Dr. Park and his colleagues then also did some work with SPF pigs where they vaccinated them, challenged them with the OSKR, and found good 100% protection at 14 and 28 days post-vaccination. And based on those results, could determine a protective titer, and then went and did the field work where they vaccinated pigs in the field and tested them and found that they had protective titers in these piglets at different times post-weaning. So we have been talking a little bit with David and Anna, the importance of testing vaccines locally. And this work certainly indicates, again, the importance of taking vaccines and using them in the field and making sure that they are actually working under your conditions. This then brings us to the combination of strains. And is it possible that if you combine different strains, that you actually broaden the immunity and that you get better protection that way? And again, some of the work that Dr. Park has shared with us is again looking at the OSKR outbreaks in South Korea, where they've seen different introductions and diversification of the virus over time. And then also saw a drift away from one of the vaccine strains being used in that area, where the R1 value started indicating that the O1 Manissa strain may not be sufficient, but the 03039 strain provides a good R1 value, indicating protection. So when they then tested the vaccine with 03039 monovalent in pigs, they found a 50% protection at 28 days post-vaccination, whereas with a combination of the two vaccine strains, they found 100% protection. Some of the work that, again, we did was together with Ida Lelystad, we found when we did this similar work in cattle, that, again, at 21 days post-vaccination, we had 100% protection in the cattle, 80% at 7 days post-vaccination. But when we used 01309 on its own, we had 100% protection, which is different from what was found in pigs. We also had a look at A22, at the serotype A viruses, to see if we find a similar synergistic effect of the vaccines. And in pigs, we had a combination of A22 Iraq and A Malaysia, and also compared it to the monovalent work. And we did this in collaboration with our colleagues at the National NCFAT in Canada. And one can see here when we did the monovalent vaccines at 21 days post-vaccination, we only had 20% protection compared to the combination of vaccines where we had 80% protection. What we don't understand at the moment is whether we are actually seeing a synergistic effect between the vaccine strains, or is it just because we are having an increased antigen payload? Because in all these combination vaccines, you are then combining 6 PD50 antigen doses in one vaccine, which of course means that you've got much more antigen. But it does show that a combination can help with your protection, once you sort of combine strains. So just in summary, there's a lot of evidence that your high potency vaccines provide sufficient heterologous protection, even when your R1 values may predict poor protection. What we have to remember is a lot of this work is done in animal trials with a small number of animals. So you can't always just correlate that to what will be happening in the field. But on the upside, these animals are mostly challenged by an unnatural route, which is either through IDL or intra-bulb, bulb, which is not the dose that an animal will receive in the field. So whenever you get good results in a small animal trial like this, we expect that you will get better results in the field where the challenge will not be as severe as under experimental conditions. It's also clear that your genetic comparisons do not always correlate with your expected R1 values and vaccine efficacy. So of course you have to look at more results before you decide on a vaccine to ensure that you don't base your choice just on one set of results. There are always benefits in vaccination, even if your clinical protection is not perfect, because we see decreased duration and levels of virus excretion, which is really helpful during a control program, where it means that you have less virus circulating in the field. The downside, of course, is vaccination does not prevent persistent infection. And more research is certainly needed regarding the relationships between heterologous and homologous potency of vaccine and the potential synergistic effect of vaccine strains. So I just want to thank all the contributors to this presentation and all the people that have collaborated in, working on these results over the years, and also the vaccine manufacturers who are providing us with the vaccine strains. Thank you very much. So we are now heading into our tea break, or just a break. And I'm not sure how much time we actually have available. Nagendra, do you have an eye on the time at the moment?
We are running 5 minutes late. I think we should come back at 15 past 25, like 10 minutes from now on. We should be back.
Right. Yeah, so on 25 past the hour, wherever you are, if everyone can come back, we'll really appreciate
10 minutes,
that.
10 minutes past.
10 minutes.
Yeah.
Yeah, a 10-minute break, so it's 25 past the hour.
Yep.
Thank you, everyone. Hello, everyone. I'm hoping that everyone has had a bit of a break. We'll maybe just give it a minute longer before we go on. I'm being told that nobody can see me. Can you see me now? Not sure. Still not. Well, my camera's on. I just don't understand. So you'll have to just sit with darkness, I'm afraid, because the light's on my camera and everything seems to be all right on my side, but
Now it's okay, Wilna.
okay. I mean, I've been giving a whole presentation looking at myself with the light on the camera, and apparently nobody can see me. So anyway, let's start. Technology is not always well explained. So I'm going to chair the rest of the session until we get to the round table. So I just want to encourage everyone to please continue posting questions. We will be having a roundtable discussion afterwards where we will then address your questions. And we have had many questions. I hope we'll be able to get to all of them. If not, we may have to have another workshop, which will be really fun. So I'm going to now introduce Elizabeth Reeder, who we will be playing a recording because it's also a ridiculous time of the morning for Elizabeth, and she has kindly agreed to be awake. So thanks, Elizabeth. Elizabeth is a senior research scientist for the US Department of Agriculture at the Plum Island Animal Diseases Center in New York. She has a PhD in biochemistry and genetics and is involved in developing novel recombinant foot-and-mouth disease vaccine technologies. She has been instrumental in generation of the first most effective infectious cDNA clone for foot-and-mouth disease virus, and is actively engaged in several international collaborations with scientists from both foot-and-mouth disease endemic and foot-and-mouth disease free countries, and has served as a scientific advisor since the creation of the Global Foot-and-Mouth Disease Research Alliance until 2018. So Elizabeth is going to tell us a little bit more about the novel vaccines that are available. Thanks, Elizabeth, and we'll start the recording.
Welcome and thanks for the invite, and also I would like to thank those colleagues that contributed with material for this presentation. I would like to give an overview of some of the novel Fndb vaccines that are coming up on the pipeline and likely to make an important contribution to the control of the disease. The Fndb inactivated vaccine has been produced in high disease containment facilities over 70 years already, and effectively used on the control of the disease. It's expected of the 2 billion doses to be sold per year, which doesn't seem to be even enough considering the number of susceptible species in need for vaccination. There is an increased demand of Fndb vaccines to serve and fulfill the needs of the 7 Fndb global pools, and very importantly on those countries on the developing world where the disease is endemic, the consequences and impact of the disease on the animal productivity trade have a direct impact on the food security. So there are important needs to help to solve these issues. The current vaccines, the conventional vaccines, have some drawback, including the fact that large volumes of the wild type is utilized for production. The adaptation sometimes could be difficult for some strains from outbreak, and also the ability to rapidly address new strains has been a concern. The vaccines are are not produced as a crude product, but require some downstream processes to eliminate the non-structured protein to make it DIVA. And even though it's expected about 3 to 5% to produce false positive due to residual contents of NSP. The vaccination doesn't prevent carrier stage. It effectively blocks clinical signs, but not the persistency or shedding or even viremia. So there are room for big improvements to just address these gaps, and where these novel vaccines are coming to play. I would briefly review in the next 15 minutes those that are coming in the pipeline and promising to provide safe and effective vaccines, improving production technologies, or providing a flexible vaccine platform to rapidly respond to new emerging strains. These include the whole virus particle with built DIVA markers, empty capsids of VLP produced in vivo and in vitro, and synthetic peptides. The first that utilize whole virus with a built-in DIVA marker is also named the Fndb Leaderless vaccine platform. The finished vaccine consists of the whole virus that has been inactivated and formulated with a proprietary oil-based adjuvant. This platform virus feature 3 key elements in it. One is a cassette construction, allowing for the easy swap of capsid that can be synthesized, DNA synthesized, and corresponding to all 7 serotypes, and addressing also new emerging strains. The second important feature is the attenuated factor that is built in, consistent on elimination of the entire leader proteins and one of the 3 VPGs or 3B. And these deletions render this virus highly attenuated both in cattle and pig. We have in this platform built 2 independent negative markers in the non-structured proteins 3B and 3D that are stably maintained and allowed for the DIVA companion test to be applied to this vaccine platform as well. An additional feature coming up from testing in recent years indicate that the combination of the vaccine virus and the proprietary adjuvant is increasing the potency of these vaccine formulations compared to the conventional vaccines. In the next slides, I just review briefly safety experiments conducted both in cattle and pigs, and there have been a number of experiments done in these 2 species using different route of inoculation, 3 of them, interlingual, aerosol, and contact and heel ball inoculation, showing a complete lack of disease or viral shedding, no fever, no transmission. And these safety studies have allowed in the US for this vaccine to be excluded from the select agent list 3 years ago, and allowing also to further development of the vaccine. A number of experiments on efficacy, selection of adjuvant, and potency have been conducted. In the next slide, I summarize the result of a recent potency test where 1 in 16 dose completely eliminated any sign of the disease. No lesions were observed. In addition, high neutralizing titers were obtained compared to the conventional vaccine. No fever, viremia, and a reduction in shedding have been observed. Interestingly, at the full dose, the vaccine prevented also persistent. 3 different commercially available NSP ELISA kits have shown to support this vaccine, These are the prior check, VMRD, and serializer. And these indicate that potentially downstream process could be simplified due to the fact that the DIVA markers are embedded in the NFP, and potentially there is no need to eliminate this protein. At the moment, these vaccines are at the stage of full development with the commercial Zoetis company, and the company is establishing a transboundary and emerging disease vaccine development facility in College Station, Texas, in collaboration with the Texas A&M University, where it's expected to produce pre-master and master seeds, scaling up production, optimization of the processes, and the development of additional full-length construct. I would like to move next to another vaccine platform that has been extensively studied, and this is for the delivery of VLPs in vivo using the ADNO Fndb vaccine platform. Originally was described by the USDA, and this vaccine is built up from a construct that has the capsid proteins and 3C, the proteinase. And this vaccine can be produced without the need of high biosecurity condition, and is compatible with DIVA testing, and doesn't contain any of the viral genomes, so making the FNDB viral genome, making it very safe. In 2005, the Department of Homeland Security took a leadership to develop this platform further. The initial experiments were focused on extending efficacy to different strains, and also demonstrating that protection at 7 days post-vaccination. Additional regulatory development efforts started in 2007, producing master cell stocks and master seed virus, testing also scaling up of the vaccine to conduct later on in 2010 a very large safety experiment that involved 500 cattle that were immunized as part of the pre-licensing series made by the manufacturer. In 2012, a conditional license was issued for the A24 serotypes, and subsequently, with the assistance of industrial partners, master seeds have been produced, and more recently, the license has been renewed with Hugh Pharma as a license holder. Now I'm going to move to the delivery of VLPs of production in a in vitro system, and the first is the one expressing the VLPs in baculovirus by the group at PeerRed. This platform features a unique mutation in the protein, in the proteinase 3C, that has had a very significant improvement on the expression due to the minimal toxicity imposed by this mutant proteinase. In addition, stabilization of the VLPs has been achieved by a number of different processes incorporating disulfide bonds, hydrophobic stacking, so improving the pH stability with important consequences in the potentially in the shell life and maintenance of the cold chain, so being less affected by changes in the temperature. These vaccines, vaccine VLPs have been now expressed for multiple strains of most serotypes, are made in a system, in a manufacturing system that is quite standard. They are entirely safe since no live virus is used. No containment, low containment manufacturing is necessary. The yields have been optimized, and it seems like the potency also compared to conventional vaccines have been worked out and look very positively compared to them. In addition to the improved storage characteristics that are conferred by the stabilization mutation, there is a safe production, quick response to new variants as they are easily synthesized and incorporated in the cassette for expression of this VLP in baculovirus. No non-structured protein, making it DIVA compatible and similar or better than current vaccines. It seems like there are experiments of cross protection being done that show that these VLP vaccines not only are more stable, but potentially more affordable as well. There are now pathways of regulatory pathway to move this to further more advanced development. The GMP manufacturing processes have been developed, and it seems like there are different documentation being provided for regulatory purposes to move this platform with several contributors listed here, including MSD as an industrial partner in these efforts. There are VLPs also produced in other systems. In this case, I'm going to just briefly review the E. coli and mammalian expression system that this work has been led by the DH group at Plum Island, where one of the key features of this platform is the use of a new mutant on the proteinase, the L127P. This particular mutation has been very effective at dramatically reducing processing of host protein, and that appeared to also increase the processing of the P1 and enhance production of VLP in all the systems they have tested it so far. This allowed for a PAM platform technology where this cassette for VLP expression could be adapted to baculovirus, adeno system, bacteria, and mammalian cell culture. The L127P made previously non-viable vaccine platform now viable due to this feature, genetic feature. One of the examples for the utility of this cassette for VLP expression was tested in bacteria platform, and here the process BP and VLP appear to form these arrays that are seen on inside the bacteria, where is a big accumulation of empty capsids inside these bacteria. And DHS has optimized the process of solubilization, and also they have tested the VLPs in animal experiment, looking at the virus neutralizing titers, and they seem to be effectively produced. There are, for the bacteria expression system, some issues on for the presence of endotoxin that are being addressed at the moment, and hopefully when those are solved, due to the flexibility and adaptability of the system, they are expecting to move that further. With very promising results, is in this slide is show the expression in the mammalian system, where the transient expression of this cassette in cell culture have been very adaptable and very promising in terms of the yields. They can be stockpiled since it's a DNA, and master seed can be rapidly scaled up for production. They are easy to adapt to new and emerging strains. No need of high containment manufacturing facilities, DIVA compatible like the other VLPs due to the lack of any non-structured proteins in the product. 100% protection in swine had, after 2 doses, have been demonstrated for the serotype O. The system is compatible with all tested serotypes and strains. and the advancing of this platform is currently undergoing with an industrial partner. I would like to now review efforts by the Spanish group on Fndb peptides, and that seems to be giving some very promising results in recent years. And this is led by the group of Francisco Sobrino, Esther Blanco, and David Andrew. The original product that was tested in 2008 was the original prototype with 4 arms expressing the antigenic site A of BP1, 4 copies of it covalently linked to a T epitope from the non-structured protein 3A. And in the initial experiment, it was very promising with 100% protection in pigs and building up a strong mucosal immunity, similar to the conventional vaccine. And also that it was shown no transmission to in-contact animals after challenge when on the vaccinated animals. Some of the issues at that time was regarding that the product was not fully homogeneous, and there were some issues on the cost because of the low yields. In recent years, better formulations and more simplified have been developed by this group and tested in the form of single valent and divalent, and with very promising result. This product now make a homogeneous, well-characterized product that could be registered as a pharmaceutical. It's feasible for industrial scaling up, and some recent experiments have brought some very promising results for the outcome of these vaccines. The B2T, that is a simplified entrimers currently under investigation, have been shown that can afford solid and long-lasting Fndb protection in swine. Current work with this modular approach are focusing on the use of in the optimization, conjugation, chemistry, and inclusions of new T-cell epitopes, taking advantage of the versatility of the system. Also on the use of different B-cell peptides to improve and try to make a multivalent vaccines built by this system. Currently, beside the protection of the intellectual properties, there are conversations with companies to move this platform into a more advanced stage. With this, I would like to just conclude this presentation, and thanks for those that contributed with their material.
Thank you very much, Elizabeth. Really appreciate the presentation. And I will now hand over to David. But David, maybe before I do, there was a question about how can you have access to the questions and answers that are being posted. And we do plan on having a short report after this meeting where we will include sort of a summary of the questions that have been posed. So I hope that helps address the question. So David is a qualified veterinary surgeon, and he worked in general veterinary practice before obtaining a postgraduate degree in immunology from the universities of Birmingham and London, and then embarked on a research career in exotic viral diseases of livestock, culminating as head of the Pirbright Laboratory of the Institute for Animal Health. David subsequently moved into the regulatory area, assuming the post of head of immunologicals, and then director of licensing at the Veterinary Medicines Directorate in the UK, before moving to the European Medicines Agency as head of veterinary medicines. During his career, he has published on epizootic diseases of livestock and on regulatory issues, particularly in relation to veterinary vaccines. David is now retired from the EMA since 2018 and provides independent advice to governmental and non-governmental bodies in relation to regulation and use of veterinary medicines. So David, if you can start sharing, please.
Can everyone see the presentation?
No, I don't.
No?
That's why.
Aha, hang on then. I know what I'm doing wrong. 2 seconds. Share screen.
That's looking promising.
And then, why isn't it going to just clear it? Sorry. I practiced this, sorry. 2 seconds, everybody.
It shows you practicing doesn't
How's
always
that?
help. No, just start. Yeah, perfect.
Good, we're off. Okay, thank you very much, Vilna, and thank you very much to the organisers for inviting me to give this presentation. What my intention to do, and I know we haven't got so much time, is to talk to you about official control of foot and mouth disease vaccine and distinguish that from other types of control. And I know that regulation is not particularly the most exciting subject for people, but hopefully I can help to get across why regulation and regulatory control can be so helpful in ensuring the quality of foot and mouth disease vaccines. So we're going to look a little bit about what we mean by testing. And actually, I think some of the questions that have come up today already show that people understand different things in terms of testing. So I'm going to talk about the principles of official control, difference really between official batch release, and that's official batch release, and independent testing. Then a little bit more detail, and some of this has already been given, but I saw some questions related to what should you be testing for. And sorry, that did that on its own. I never touched anything. And then we'll finish off with a few key messages. So this slide might look a little bit busy and a little bit complicated, and maybe we'll need to come back to it later. But there's a few points I wanted to make. So if we look along the top, we see who is going to do the testing that we are talking about when we talk about testing. And we talk about the manufacturer, an independent laboratory, and official control. And so one key issue is whenever we talk about testing by independent labs or by official labs, we're talking about retesting. We must always remember that actually that product has been tested by the manufacturer very extensively before it's released onto the market. And you know, we don't want really to forget that everything is to do with retesting. So, and then if we look, I'm going to jump, and you can see that the testing is done at these different stages. It's very useful to think about the life cycle approach of the vaccine and why are you doing testing at different stages. And again, as I say, I haven't got time to go into all this. It might be useful if we come back again. But essentially, you get a vaccine, you develop it, you check its quality, and you check that it's fit for purpose, and then you reflect that information on the label and in the authorization that's approved. And thereafter, official control authorities are interested in checking that the product that is being released is exactly, and I mean exactly, what is written into that authorization. And if it says it's 3PD50, then you need to show that it's 3PD50 and be able to verify it. If it says that it protects against a certain strain, that information should be available in the dossier. So again, as I say, I could talk for a long time to this, but just to look at three things. So if we're talking about official control, which is what this talk is about, there are really three stages for official control. One is before you get your authorization, the official authority may want to actually test the product. And again, I didn't and some countries do that routinely. In the US, they'll always do that. In Europe, quite rarely actually, and other countries vary. And so that's to say, we're going to give you a license for this. we're going to test that it is actually like the product you have in your description. Then there's official control authority batch release. So that is saying the manufacturer says this batch complies with the specifications. I'm going to now release it onto the market. And for some vaccines, authorities like to check that, and we'll come into that for foot and mouth disease. And then there's the question of, okay, you've got a product on the market, you're going to go out as an official authority and check that that product, once it's on the market, is actually compliant and of good quality. So I think there's a couple of points about retesting in terms of high principles. And the first is you can't test quality into a product. You have to, it has to be built into the product. And that's what the system of authorization does. And it doesn't just look at the product, it looks at the three aspects of, is the where the vaccine is produced a suitable facility? Does it have everything it needs? Do they do what they say they do? Do they have the documentation to prove it? Then you want to have a look at a dossier of information that says this is how we produce the vaccine and this is the standards that it meets. And you have a look at that and say, yes, it does or it doesn't. And then you can do the retesting and the post-approval monitoring to say, okay, does this product that I've got actually meet the requirements? And there's different ways of doing. Now, different regions have very different approaches in terms of how and when and if they do retesting of products. Some countries, and again, US is one, every single batch released has to send a sample to the control lab, and that may or may not be tested. Some do it on a random basis, some do it targeted, some do it for everything, and some don't do any testing at all. So you can see how it's applied is very variable. What I would say is that where you're talking about foot and mouth disease, which is normally part of a government eradication or control policy, it is quite normal to do some form of batch release. In other words, to check that the product, when it leaves the manufacturer's doors, of good and of the quality that they state. So just a little word about the difference between official control testing and independent testing. That's carried out under the authority. It might not be by the National Regulatory Authority, so they may use an independent lab. Check that it complies with the agreed specifications. Independent labs will generally be testing against international standards or set by the customer. So it's not necessarily, they may not actually be testing compliance with the other interests around so I do draw that distinction in the presentation. So key factors that are involved in the defined in the OIE, regions may impose additional or higher requirements for product international.
David, I don't know.
For foot and mouth.
Sorry, David.
Yes.
David, it's Vilna here. Sorry to interrupt so rudely. You are breaking up, so I wonder if you would mind just switching off your video, please.
Hang on. Okay, I hope that will be better. Okay, and as to what people mean, and they often confuse innocuity, which is demonstration of live virus, with safety, which is the amount of reaction that a vaccine causes in an animal, and also sterility versus purity. And that's because different countries and different regions use different terms for the same thing. But on this slide, I've effectively defined, as you will find in the OIE, what each of those terms means. And for official control testing, just pointing out in the final bullet that one of the biggest challenges is, of course, that for foot and mouth disease, you can only test most of these parameters in secure laboratories. So that severely limits the ability to test, and why independent laboratories with appropriate biosecurity are often used for testing, particularly for innocuity and potency. And now my slide. Okay. So innocuity, just a couple of words. It's obviously one of the key parameters because you want to be absolutely sure that importation and use of your vaccine does not spread live virus. And this becomes even more important as countries become free, and essentially any strain of foot and mouth disease would be considered exotic to that country. It's also an issue where you have, and in Vilna's talk, she showed very, very well that often the strains that are most effective may not be natural to the region in which they're going to be used. They just happen to be very good and very potent vaccine strains. And if authorities are going to allow them to be used, they want a lot of assurance on innocuity. And so for foot and mouth, there are these particular requirements that I think most people are aware of. You know, you have to use a first order inactivant, normally BEI, and you have to fully validate the inactivation procedure. And almost uniquely, not quite, but almost uniquely, you have to confirm the kinetics of inactivation for each batch of antigen. In other words, demonstrate, as on the next slide, that you do indeed have linear inactivation, that at the end of the period, or you extrapolate to show the end of the period, and you will see that you have less than one infectious virus per 10 to the 4 liters. And this slide, I think, is an excellent one for just summarizing the key points on innocuity in a single slide: linear inactivation, kinetics, appropriate endpoint, and a reminder why we no longer use formaldehyde for inactivation. Activating FMD. And then finally, you kind of you have belt and braces, because at the end you then control the inactivation for each batch of antigen using an amount of antigen equivalent to 200 doses of vaccine. And so the thing, of course, is it's very difficult to independently verify this as someone who is not the manufacturer. So you may, most manufacturers or most control authorities will want to see the documentation demonstrating that this is indeed what manufacturers apply. So just a final word on innocuity. The OIE manual talks about a test of innocuity on the final product. In fact, that's extremely difficult to do because you have to elute the antigen from the vaccine. And adjuvants and excipients do often interfere with the ability for cell culture. So if a laboratory is going to do this, they have to validate their own test for each product that they do, and it often requires a different protocol. So what does that mean? It means that actually, if you're going to test for innocuity, it's best done on the final concentrated bulk inactivated antigen, where you can test the equivalent of many doses, because of course testing for innocuity is a statistical exercise, a numbers game, and this gives you the greatest chance of detecting residual live virus. And some countries actually make it a condition of authorization that manufacturers supply samples of the bulk inactivated antigen for retesting. So that's something one could always consider. So then moving on to potency, I think I can whiz through most of this because Vilna said quite a lot and David did originally as well. I think what I would emphasize is that for licensing, you know, people say, well, why do you test the potency against homologous virus? The answer is because that's the only way you can actually get a standard, that if you are using the same challenge virus as you are in the vaccine, you have a very clear standard against which you can measure. If you use any other strain, you immediately start to introduce variation and questions about the relationship between the two. But of course, it does then mean that what you're measuring is the ability of the vaccine to protect under the best possible circumstances, and therefore looking at antigenic relevance, or the, you know, how well will that vaccine protect against field strains. That's not done by the batch potency test. That is done by other testing that the manufacturer should submit as part of the dossier to demonstrate, first of all, the relevance of the vaccine strain. That's in the quality part of the dossier, and then demonstrate the efficacy. And then, you know, if they say on their label that it protects against a certain strain, there needs to be evidence that it does. But you know, the definitive test is the in vivo challenge, using one of the defined protocols that Wilhelm described. And manufacturers can certainly use serological tests, but one way or another, it should always be possible to correlate that serological test, the results from that test and the cutoff used, to protection in a cattle chest. And that is done by correlation studies. It's certainly possible to reference published material, but the manufacturer needs to demonstrate that that published material is relevant for their own vaccine. So in fact, it's very difficult, or it's not difficult, but it requires quite a lot of work for an independent testing laboratory to replicate the batch potency test. In other words, check that each batch of vaccine on the market complies with the authorization. And that would normally require cooperation with the manufacturer and transfer of technology. And you know, that's indeed what happens in South America and used to happen in Europe, and it is something that is, as I say, if you're doing official control, then that's normally the way that that will be done. So sorry, I'm just checking, my slides seem to change on their own mind. Okay. And the final point on that slide is that you should, somewhere in the dossier for a registered product, always have at least one challenge trial for what each strain included on the authorization. And now that may sound obvious, but it isn't always the case, and it's something that should actually be checked, that somewhere that vaccine strain has been tested by challenge against homologous or other viruses, but somewhere it should have been checked. Okay, so I've covered the points on this, and the final point I just wanted to make was just to mention another project that I think is relevant just to talk about here, and what we have been talking about is distinguish between the quality of the vaccine and its fitness for purpose. And the purpose of batch release and official control is to demonstrate the quality of the product and that it meets the claims made for it on the label. And I'm working with EuFMD and FAO to try and develop a pre-qualification system similar to the one that operates for WHO for human vaccines that are, and so any vaccine used in a UN human vaccination program has to be pre-qualified by WHO, and we would like to put in place a similar system for foot and mouth disease vaccines in the first instance, and then other vaccines thereafter. And that would look at the issues, as I say, around, is this a high quality vaccine produced in a good facility? does it meet the claims made on the label? It would not then look at is it fit for purpose in particular epidemiological circumstances, because that's really a question that is up to the customer, and the customer may well wish to use an independent laboratory to verify that. So it's been a bit of a gallop through, but I hope that was relevant to the discussion. So these are, I think, my few key message. Official control looks at, is it the product that it says it is? Independent testing will look at any of the issues that are important for people wanting to use vaccines. Actually, you can get an awful lot of information from looking at documentation supplied by the manufacturer without even going to the laboratory, and one should always start there. And then actual, retesting if possible, cooperation with manufacturers, and just the final point, that retesting supplements but does not replace the need for a good quality vaccine in the first place. Thank you very much.
Thank you very much, David. And I will now invite all, if you can stop sharing, please. And I will invite all our panel members and our two moderators to join us online. So I just quickly want to introduce our moderators. Theo has started his career as a clinical vet in the UK and South Africa, after which he specialized in veterinary epidemiology and public health, working in Europe, Africa, and Central Asia. He obtained his PhD in the evaluation of foot and mouth disease vaccination programs, working in Turkey and Iran, and was a co-author of the FAO OIE international guidelines on the topic. In his current role as senior scientist for the International Livestock Research Institute in Kenya, Theo leads a research program looking at food safety risks in the urban food markets in Africa. And he also leads activities in Ethiopia for the Global Burden of Animal Diseases program. So thank you, Theo. And Kees van Manen is our other moderator who studied veterinary medicine in the Netherlands. And after his graduation, he became head of the laboratory for foot and mouth disease vaccine control, diagnosis of vesicular diseases and equine viral diseases at the Central Veterinary Institute in Lelystad in the Netherlands. And in 1992, he joined GD Animal Health, where he was the head of the R&D development, R&D laboratory between 1995 and 2013. His current position at GD Animal Health is as a virologist and senior scientist, and his main research interests are in equine infectious diseases, emerging diseases, transboundary animal diseases, test development, test validation, and the implementation of diagnostic strategies in the context of compulsory or voluntary disease control and eradication programs. So I'm going to now hand us all over into the capable hands of Theo and Kees, and welcome all our panel members online.
Thank you very much, Wilna. I hope you can hear me quite well. Theo, if you allow me, I will make a start. Okay, the first question I would, to get the discussion going is to David. We have been hearing about post-vaccination monitoring, but how widely is PVM used in different parts of the world and for different vaccination systems? And if it is not widely used, why not?
Yes, so I think it varies a great deal. So in some parts of the world, for instance, in South America, where there's a long experience in organizing very large-scale vaccination campaigns, it's used on a very, very regular basis, and they have very good systems. And I think they know exactly what they are doing with the monitoring programs. But in other parts of the world, perhaps especially where vaccination is done on a more spasmodic basis, I think there's almost no post-vaccination monitoring done at all, or else if it's done in a very haphazard way. So I think that's one of the key messages, as indeed Ronello made at the very beginning of this seminar, that probably we do need to put a bit more effort into our post-vaccination monitoring. And perhaps one other quick point is that even for countries that might be free of the disease and use foot and mouth disease as an emergency vaccination measure, there's a growing pressure, I think, to use post-vaccination monitoring as part of your evidence when you're trying to recover the free status. Over.
Thank you, David.
I have a question that it applies to several of the panel members, so others can chip in, but I'll first ask Anna. In all the various talks, we quite often talk about thresholds, and there are quite a lot of questions about use of them. So we had a correlation and thresholds for titers and protection, and I think Wilhelm mentioned a rule of thumb use of 3 PD50 versus 6 PD50 in different settings. Would you like to say a little bit about this and how policy makers or those planning campaigns and designing them should use these thresholds, looking at serology maybe, or as you choose?
Yeah, thank you, Theo, for the question, because to be honest, it was something that I probably missed in my talk, and I should have gone into more detail. I think firstly, it's really, really important to realize that at the moment, the assays, so we're talking about the ELISAs and the virus neutralization tests, are not harmonized between different laboratories and different reference laboratories. So at the moment, the cutoffs that I'm describing are the cutoffs that I've used in my lab at the World Reference Laboratory, but each lab must come up with their own cutoffs, and they may be lower or higher depending on what virus neutralization test or what ELISAs they're using. At the moment, we are still trying to figure out what the protection cutoff should be for the virus neutralization test within the World Reference Laboratory. And we have moved quite a bit forward in that space, thanks to the OIE FAO network providing us serum that is before the animals were challenged. But I think we're still a little bit away from defining those cutoffs. So the 1.5 cutoff that you saw on my slides, for instance, were specific for an ag results competition that is taking place in Africa and shouldn't be used as the cutoffs. But I think it's an area where we always talk about cutoffs, but having done a lot of these post-vaccination studies, even if you don't know what the cutoffs exactly should be, you can get a very good idea of vaccines that are giving basically no response against your reference panel or whatever you're testing to vaccines that actually give some response. And again, you can then start playing with whether or not you need to booster those or what your vaccine should look like. And as David mentioned in his talk, from what we've seen in the literature, you probably don't need that high of an antibody titer to get protection. I don't know, David, if you wanted to say anything more on that, or Don.
Well, the only thing, may I, Theo?
Oh, yes,
Yes.
please go ahead.
I mean, the only thing I would go back to is the point I made in my talk, that it's quite difficult to have high precision about predicting protection. And I think perhaps it's useful, therefore, to separate what you're trying. Certainly when you do population immunity studies, I think the main aim is to find out whether you've done the vaccination properly. I think for that, you actually need to know what titers of antibody you can expect to get from your vaccine at a given time after a given regime. And that's what you should be checking that you're getting in the field first and foremost. It's a little bit of secondary consideration how much protection you get as a result of that. And I think also when you come to select the vaccine, you should do a good job at that stage to make sure you select a vaccine that's likely to give protection. And then again, the population immunity study is mainly to show that the vaccination has been done properly and that you have indeed got the titers that you expect to have. And maybe a small part of the sero can be subject to some more intensive studies to actually try to decide about protection over.
Thank you. Thank you. May I add a few words to this, Theo? Just a question to Anna. We had another question related to this. The harmonizing of virus neutralization tests. How is that even possible when cell type, cell passages, and history and virus passage history differ between labs?
Excellent question. So actually, we're looking at this at the moment through an EuFMD FAR grant, in which we will be carrying out an equivalent study. I think a key to this will be to have reference serum and calibrated serum that we know how it behaves in labs, so different labs can adjust their neutralization titers. But yes, I think you're right. I think it's something that we always talk about, but it will take some time. We're also looking at using different cell lines at the moment as well. So using the LFBK alpha B beta 6 in our lab as well, which would be the type of cell line that then can be shared across all of the different labs. But yes, I agree. It's something that's overdue, but we are working on it, and it will be a challenge, but hopefully we'll be successful.
Thank you.
I was just going to mention we're lucky that John King has joined us on the panel, so head of a World Reference Laboratory for foot and mouth disease at Pirbright. So I've got a question for you, Don, but again, it applies to many of the people. So when people we've had a question about testing vaccines, often it's, one dose, or do they include a prime boost, 30 days later? Well, do you have thoughts about that and what do we use? And also, when we're testing, we're often only looking at one dose. Should we be evaluating more the effect of the 2-dose for vaccination?
Yeah, thanks, Theo. Thanks for the question. I'm very pleased to join the discussions today. I mean, this is a very important question, I think, because if you look at the metrics for defining vaccine performance, it's often taken at this 21 days. But of course, in the field, the animals are not going to be infected at 21 days post-vaccination. They are infected at a whole range of different dates after vaccination. And quite often, the vaccines are given in 2 doses. And so bringing the argument from the very rigid process that we have at the moment, which is defining the serological values at 21 days and moving much more into understanding what you expect to see across the whole range of the period at which the animal is vaccinated and the waning of the immunity that would be expected over a period of time between the points at which animals are vaccinated. I think that's quite critical. And I'd say, within the literature, there's very little data to support those values. And as David highlighted in his presentation, this is a big gap, I think, for the GFRA community, if you like. And I think it's something that perhaps we recognize within the reference laboratory network. And I think there is definitely opportunities for further studies to be done in the field where animals are vaccinated and serum samples are collected at different points after vaccination and tested. And I would say, from our side, from a World Reference Laboratory perspective side, if people are thinking of doing those types of studies, please feel free to contact us. We'd be very happy to be involved and perhaps even help with the testing.
Thank you very much, Don.
Just a comment on that, because I think it's an important thing around, you asked about standards and so on.
Right, David.
Is that okay?
Yeah.
Okay, yeah, just to say, I think in terms of foot and mouth testing, it helps to distinguish potency from efficacy, because we're often kind of blurring the 2 issues here. And when we talk about potency, it's really an issue around quality. In other words, what is the immunogenic potential of that vaccine? And that is what you measure in the potency test, and that can be standardized. So you can say, is that an immunogenic and potent vaccine? And in both the OIE manual and the European Pharmacopoeia, they have considered that a vaccine of 3 PD50 is the minimum acceptable potency. But in terms of stronger vaccines like emergency vaccines or others that might be suitable for use with a single dose, it carefully doesn't define what PD50 you require for that. It suggests that vaccines should be 6 or more. But then you look at efficacy, which is clearly closely related to potency, but also involves the vaccination schedule and you know, how many vaccines, what interval, what's the onset of immunity, what's the duration of immunity, and that is included in the efficacy section of a dossier, and is a separate, well, it's a separate but related issue to potency, and so potency for foot and mouth disease vaccines, yes, it is very linked to efficacy, but from a kind of how you evaluate that vaccine for deciding does it do what it says it does, you need to put together both the potency and the efficacy.
Thank you very much, David. I would like to have to ask a connected question to both Davids and also to Wilna, and that is about, we talked about the variability of virus neutralization tests, but let's talk a little bit about the variability of potency tests. What is your opinion about that? And can you even distinguish between 3 and 6 PD50?
That's probably a question best asked to the vaccine manufacturers, but yes, it's absolutely correct. We know that the potency values are very hard to calibrate and that they are incredibly variable between testing. And my personal opinion is that we should probably move away from actually having 3 and 6 PD50s and just have a single standard for vaccines where we say a vaccine should have a certain amount of antigen in it, where we know that we'll get good protection, well, good potency and good efficacy, and be effective in the field. And especially if you look at the results that I've shown and shared with you, where a high potency vaccine will provide protection, even if you don't expect that good protection based on the R values, which of course also has a lot of variation involved in measuring. And therefore, shouldn't we rather be looking at just one standard of vaccines and say, yes, it is hard to distinguish between a 3 and a 6. Let's rather say that we want a certain standard that is the highest level and ensure that animals will be protected. David, you want to jump in?
Yeah, sure. Yeah, I mean, I think from a regulatory point of view, it's often the case that tests that have been used for decades, like the cattle challenge test, become the gold standard, even though when you actually start to pick away all of the validation and statistical certainty, yes, you certainly see that they may not be as accurate or predictable or reproducible as you'd like. I mean, I think the fact when you do a full PD50 challenge trial with graded doses, then you do get a very good idea as to the quality of the vaccine. But I agree with you, the statistical certainty. The problem is, you know, and if that test was put forward now as a new test for inclusion into a pharmacopoeia, it probably wouldn't be accepted. But that applies to a very large proportion of tests that are already in pharmacopoeias that define what is the acceptable minimum standard. I think in its defense, it has withstood the test of time, and there are other pharmacopoeial standards which people ultimately come to soon realize don't work. You know, they're not high enough. But that there hasn't really been much of a cry to change the pharmacopoeial standard, other than to maybe define what dose would be necessary for a single dose regime, in other words, an emergency vaccination. But I think because of foot and mouth having such wide differences in application, you know, is it an emergency, is it ring vaccine, is it routine vaccination, and then you need different vaccines to fit those different purposes. And I hate to say it, but economics then comes into it, because 3PD50 is probably the lowest dose you can get away with. That produces the cheapest vaccine that is shown to be effective, and that seems to be generally agreed and why they'd stick with it. But economics comes into it in terms of you can put in as much as that antigen as you want, but it's going to cost a fortune.
that maybe brings us on to just another area. So, in Elizabeth, in your talk, you talked about all these exciting developments, some that have been progressing for some time for novel foot and mouth disease vaccines. With the current inactivated vaccines, they've played a major role in FMD control in different parts of the world, but yet in many other areas, often because of economics, they haven't been able to deliver widespread control. Do you think there's any major breakthrough on the horizon now, where there's either a major breakthrough improved vaccine? It could be just as good but cheaper to make, better cold chains, any major advantages that are likely to happen in our next few years?
Yeah, I think that with what you saw in the presentation, there are some of these novel vaccine actually advancing to a level where production could be achieved in the near future. And of course, the advantage of some of this is that the requirement now of biocontainment that are not of the high level as the production of the current vaccines, and that could add to the lowering the cost, and the fact that they also are produced from DNA. The aspect of producing and stockpiling this DNA for scaling up bring another advantage. So if precious strain get lost, you always have this at the DNA format, and could provide a source to just scale up and produce this very quickly. The adaptability is other feature that I mentioned. And I think this platform are now advancing with the contribution of the industrial sector. And that is, I think, what is making this platform very promising, as they are further developing into a real product being scaling up. So I think that there is a lot of hope for the near future. And again, these novel vaccines could fulfill certain purposes, so and be complementary to the conventional vaccines that are already being distributed. I think there's room, and there is potential to really provide all the needs that are required, and potentially provide a lower cost post production. So that's the two main features that I think this seems to give a lot of hopes for the near future in terms of production.
Thank you.
Could you could I continue a little bit on that, Theo?
Yes, please go ahead, Kees.
I would like to tease Elizabeth a little bit more. We are still in the COVID-19 pandemic, and what have we learned from the in terms of accelerated development and registration of vaccines? And are there any of these COVID-19 platforms that could be attractive for FMD vaccine development also? And connected to that, on which new development would you set your cards?
Yeah, well, that is a good question, and I think I would say all the molecular component of building up these novel vaccines is very straightforward and fast. The regulatory component is probably what getting the registration and the release, especially with the emerging strains, is the part that probably take the most time. Not the production of the new constructs and the new prototypes vaccine, but that regulatory. And I think we may need to work to speed up that type of processes based, as you well exemplify with the experience with COVID. I think the successful platforms used on the COVID vaccines are also being explored with the Fndb, and we have the adeno, we have mRNAs, we have these DNAs that I just show you several examples in my presentation. So I think the platforms are there. We need to probably speed up the regulatory aspect of getting a new and emerging strains up to the front line. I hope that answered my question, but perhaps David could add more into that regulatory aspect, how we could speed up that.
And just to add before we pass back over to David, we say in the near future, if you had to give broad timelines for getting a new vaccine out onto the market, again, COVID, in these times they do it in a year or two. What is possible for foot and mouth disease vaccine? If we have a good one and a good one that's proved looks promising in the lab to actually get it to production.
Yeah, as I said, the process of producing a synthetic DNA containing the new capsids that you want to express in any of these platforms could be really available within a week. And then the cloning and the expression, remember that this platform could easily produce the product in a process that is already free of extraneous agents, for instance. So you have a certain step that you could have ready for this construct to be delivered and processed and produced in a condition that is already close to be released as a product. So there are some advantages, and again, I think this seems to be a rather rapid process where you could just transfect into the system, express it already on a cell line, for instance, for the Leaderless vaccine platform, and have a do direct production in the manufacturing suspension cell, just to give you an example.
Thanks.
I hope that answered the question.
Yes, and David Mackay, do you have thoughts about the time it takes to get, if someone came along to you, well, to the regulator with a good vaccine that's working in the lab and working in production, it looks promising, they've got an output, how long does it take to then get through the regulatory process?
I mean, in principle, in most areas, you can get accelerated timetables of around 150 days and general ones of around 210 days. So you're talking roughly a year, but that doesn't include the time taken by manufacturers to answer questions. I think, you're absolutely right, Elizabeth. It's been fascinating to watch COVID because it shows what regulators can do when they're under an enormous amount of political pressure to accelerate. This wouldn't happen in normal times. It would have taken years to think how quickly they licensed the first mRNA vaccine in humans is absolutely astonishing and shows what can be done. I mean, the general guidelines exist, so it will depend on the technology. I think what people are hoping is that you can license the platform technologies, and that depends a bit on the region. In fact, the US is quite advanced on that and have a system for licensing platforms. I'm not aware of any other global regulatory regimes for licensing platforms. In other words, you get your platform licensed and then you can just chop and change and swap in your whatever insert that you want to put in. And as I say, US has a system for that, but no one else. Europe is gradually making its way, and the legislation's in place, and probably in a couple of years it will. But that doesn't stop kind of immediate licensing of a product in using a conventional method. So I think, Theo, it depends a bit on the technology. If it's inactivated and follows some kind of technologies that have been licensed before, it could well only take a year or so, and much less if there was a real disease emergency. But if you want to get the concepts behind many of these new technologies, yes, but regulators are always about 5 years behind the edge of science, but they are there and they are following.
Okay, thank you very much. Maybe on another topic, I think Anna told a very interesting story about the work in East Africa and the selection of field reference strains, and in combination with AU PenVac. And one of the questions is, we don't have an AU PenVac in Asia, so how should we proceed in our region? And the other question I would have related to this is, do you think, and maybe Don can also comment on that, do you think that the viral intelligence is in East Africa and maybe also in Asia is good enough to select the appropriate or relevant field strains, or are we going to miss something?
So maybe I can answer the first question and then I'll pass it over to Don. I think it's a very good question about what should happen in Asia and who that body should be. But I do think there are networks already in Asia, like, such as CSC, FMD, and other meetings that happen throughout the year where this can be discussed. I think it needs to be a joint effort. And I think, you know, it's something that the networks need to decide how they want to go about it. But I think the key thing is that it needs to be an approach that people don't go away and do individually, but rather a collaboration between all of the different countries and all of the different players, because it doesn't make sense to me for everyone to do it individually, as, you know, working together will decrease the cost and will allow us to get more knowledge. But of course, the World Reference Lab can always help there with what strains are available and how we've gone about it with EuPanVac. Don, did you want to say anything else?
Well, perhaps just to add to what you've said, Anna, I mean, you're right, there's no formal laboratory located in the region, such as EuPanVac, but I think there are some very simple things that could be done to start the process rolling. You know, for example, it would be a relatively simple matter to have agreement between the countries in the region to define what might be considered reference antigens that would be representative of the circulating strains. And then we could put together a small program of work to get those antigens supplied to the laboratories, so that at least if for those labs that are using VNT, they can use the same antigens in the VNTs, and that aspect of the testing can be harmonized in a very straightforward manner. And I'd say that again is building on the model that we've used in East Africa. I mean, this is not rocket science. This is a relatively simple thing that could be done. It would help us being able to compare the results as they are generated in different laboratories at different times with different samples. So that would just be a very simple suggestion. Moving on, I mean, the second question perhaps is a slightly loaded question from Case, which is the extent to which surveillance in the endemic countries provides an overall representation of what is present. And I'd say, you know, we've seen a lot of efforts in the last 5 to 10 years to increase surveillance for FMD in endemic countries. Of course, in the last year or so, that has been hit a little bit by COVID, but very much we hope that we can have sort of a rebound after COVID, and a lot more samples can be collected, and perhaps we can get back to the position we were in before. I mean, I'd say in terms of these regional antigens, again, this is not difficult. It's not difficult to keep this under review, and if needed, they can be changed. So I'd say, I mean, they're based on our most active intelligence, but it doesn't necessarily mean they need to be fixed.
I mean, just to add to that, it's important to say that this is complementary to the existing work with R values and monitoring strains. So you might have a regional panel, but you would still want to collect more strains and find out if something new comes along over.
Thank you. Looking at the clock, I see we could keep talking for another hour, but we're actually already slightly over our time. I'd like to just, one last point, ask Juan Labilo if he has any reflections on the last points or any of the topics that come up here, they think are particularly relevant, before then passing it over to Vilna to wrap up and close the session. If Ronella is there, if you can hear me, otherwise, I'll hand over to Vilna. Maybe she can carry on.
All right. Yeah, so it actually just leaves us now to say thank you very much to everyone else who has joined us. We really appreciate your time, appreciate the time from all our presenters who's put a lot of effort in preparing and presenting today, and especially people who had to get up very early and probably didn't even sleep last night. Really appreciate that. So I'll just hand over briefly to Nagendra to say a few words, and then Fabrizio, you get the last word for the night. You're on mute, Nagendra. You're still on mute.
Okay. I have to make a joke of myself. Yeah. I'd like to thank all the presenters for doing a wonderful job and bringing their knowledge and experience on the different aspects of vaccine, quality control, and then application, and then for the monitoring of vaccine efficacy or vaccine monitoring in the field. The success or failure will depend upon how we procure the vaccines, store them, transport them, how they reach the far places in difficult terrains in Asian conditions, and then how best the vaccine manufacturers can provide them with a good vaccine for application in the field. I'd like to thank FAO EuFMD for all the help that they have rendered in organizing this conference or workshop, especially Fabrizio, Nadia, Alessandra, Ludovico, and Costanza. OIE CCFMD for helping us to bring all the people together in our region in CCFMD. GFTADS, FAO and Nepal for helping us to bring people from South Asia, especially Dr. Kadak Singh Bisht. The Purport Institute for helping us to reach out to people in West Eurasia. Dr. Carissa Miller for organizing people within Australia as well as in the Pacifics. Dr. Zedong Zhang and Dr. Yan Min for bringing all the people in the Chinese Academy of Sciences to participate in this event. Dr. Jeon Park from South Korea for providing his slides and helping us to organize this event. And finally, Chair Alessandra from the GFRA for allowing us to organize this event under the banner of GFRA and EuFMD. So thank you one and all. And I also thank the moderators, Keys and Tube, for helping us to organize the discussion part, and my co-repertoire, Petrus, and then my co-chair, Vilna. Thank you very much.
Thank you. And yeah, thank you, Nagendra. And probably the last word is done for Ronello. And I saw that also Alejandra joined us through the chat. Well, just saying that at the Wilna, at the presentation that you gave at the very beginning, I saw that a lot of participants, not only from this region, and I really think that this conversation and discussion held today is useful for the whole world. As I mentioned at the beginning, in our program, we have several aspects related to vaccinology, and we are very much looking at the, the protection provided by the vaccines that there are in the European Vaccine Bank to different strains that are considered at high risk for Europe, being an European Commission, as well as processes to ensure quicker availability of vaccine with proper quality, safety, and efficacy. So I hope that, as I said, that this discussions today was useful for a lot of scientists and experts around the world, and I think that showed the level of the number of questions and the level of discussion show the highest interest in this topic in this region and all around the world. So Nagendra, you have thanked all the relevant speakers, moderators, and all the staff that has assisted in that, and I would like finally to thank you and Wilna for having actually organized this. Thank you.
Ronaldo, your final, sorry, Ronaldo's remarks, if any. Ronaldo, please.
Yes, just to re-echo again what Fabricio said, that to thank Wilna and Ajendra for really spending a lot of efforts with the support of EuFMD in organizing this, and also to thank all the participants from all over the world, particularly from Asia and my colleagues from the CCFMD countries. There's a lot of knowledge that we have really acquired from listening from this webinar tonight. And this will be continuing discussions. There will be a continuing discussion among those who are involved in FMD control in the region and also globally. And we are really thankful for all the resource speakers for imparting their knowledge on this. And we look forward for a better way on how to control FMD with the application of quality vaccines in our region. Thank you.
Thanks, Ronaldo. So it is then au revoir, good morning, good night. Everyone enjoy your day.
Same to you. Thank you.
Bye,
Bye-bye.
everyone.